And thank you all for coming to Carleton for Data Day 5. So I understand there are more than 400 people expected to attend today, so that's fantastic. Every year the number grows more. So as you know, data plays a vital role in our life, and that role keep increasing every day now. So if you look around you and see what's happening in the area of health, in the area of transportation, in the area of finance, in the area of public safety, you'll find that data now is becoming so vital to our operation that it's becoming essential in everything we do in every time in our life. So data is becoming also extremely valuable. So you find a lot of companies nowadays, and you try to see what are you selling, and you find that at the end they do mining of data, analysis of data, and so on, because now with all of the data that's available out there, there's a lot of information that you can extract. So as I said many times before, the problem we had in the past was we did not have enough data to make good decisions. Now we have too much data that we cannot make good decisions, because we need to have lots of ways of analyzing this data. So when it comes to data, there is the data acquisition. So data acquisition includes data that's available in databases, financial databases, electronic health record databases. Then there is data that's added to these databases regularly. And there's real-time data that comes. I'll give you some examples in a minute. So if we look, for example, at the area of health, for example, before you used to have a medical doctor. You go to that medical doctor, they run a few randomized control trials to see what works and what doesn't work. This is published in some papers, and then it becomes a trial, it becomes what you teach doctors, and then it stops there. And doctors can share information in conferences, in meetings, and so on. But nowadays, with the electronic health records being available, so systems would know what medications you're taking, with the data that related to your health is being recorded in terms of blood pressure, in terms of lab tests, and so on. And now with wearable devices that transmit a lot of information about your vital signs going there as well, we have like one of the largest randomized control trials that you can think of, because you have all sorts of data coming from individuals, you have outcomes being there, you have real-time data, non-real-time data. So actually, if you look at this wealth of information and what it means to society, it's actually huge. So let's talk a little bit about data. So what do you need to do with data? First of all, there is the data acquisition aspect, which is, well, we think of data acquisition as entering the data into databases and so on. But right now, with everything that's happening, as I mentioned, wearable devices, we're talking about cars now that are equipped, like every car now, almost every car in the market have got an OBD2 port that actually collects a lot of data from the car, and this information now is stored somewhere. So you have a lot of information about transportation. You have a lot of information about profiling, security, and so on. Even the photos that you take with your phone. I mean, we're talking now about face recognition systems. We're talking about place, face, activities. So you can link all of that together, and it becomes like a wealth of information that could help us. But also, it could cause us a lot of problems with respect to privacy, security, and so on. So let's think about data in general and think about what are the various issues or opportunities existing in the data field. So first of all, the data acquisition. There are many, many companies right now working on some systems for data acquisition, whether it's portable devices, whether it's using the phone to acquire a lot more information. Then you have transportation, which is taking the data from wherever it's collected and feeding it into large databases. But then at the end, you have all of this data you don't know what to do with. So I guess the vital area that we're going to be seeing in the future is the area of analyzing the data or extracting useful information from this data, whether it's municipal level, whether it's federal level, whether it's personal level, and extracting that information. And this field existed in many, many years. So it used to be called at some point signal processing, or it used to be called long time ago expert systems, then artificial intelligence, then it became neural networks, then it became deep learning, and now AI is coming back, and then data analytics. So there are lots of words that have been used to different aspects of analyzing the data, whether it's real-time data or whether it's databases that we're collecting. So I remember a couple of years ago, there were discussions at the Global Engineering Deans Council, and there we're talking about what are the fields in the area of engineering that would make a huge difference. And there was almost unanimous agreement there that the area of data analysis is becoming vital to every field around us. So in the field of engineering, if you look at what's happening in construction, what's happening in smart buildings, what's happening in aerospace, what's happening in communications, you'll find that at the end, people are there having lots of data, analyzing the data, and trying to extract useful information out of that data. On the financial side, on the science side, even on public policy right now, the data that's available to make the right public policy and regulations is becoming more and more available. So again, these tools that we're talking about here in terms of how to analyze the data is not uniquely useful for the area of data analytics, but it's useful to each and every field around us, whether we're talking about engineering, we're talking about science, we're talking about public policy, even we're talking about arts, talking about business, talking about finance. It's becoming the key area. And that's why we find that graduates from the field of data analytics, of big data, or data mining are snapped like this by industry. So we at Carleton have realized that a few years ago, and we've started a lot of programs, whether we're talking about undergraduate programs, graduate programs, specialized ones, or general collaborative graduate programs, and we'll talk about that in a minute. But in the meantime, I want to tell you as well that sometimes when you talk to one individual about data, data analytic, deep learning, AI, they will think about it in their own perspective, whereas in fact, if you think about it from any perspective whatsoever, you'll find that what at the end of the day people are doing these days is analyzing data. The challenge that we're going to have in the future will be the vulnerability that we have with all of this data being out. What is the impact on privacy? What is the impact on affecting data integrity? What is the impact of destroying some of this data or corrupting some of this data? And how would it be affecting us? And in the transport as well, like when we're talking about smart homes, for example, we're saying, well, my HVAC, heating, ventilation, air conditioning system is controlled by where I am, and then the fridge is controlled by that. I have an Internet of Things, and the security, the heating, the cooling, everything there is controlled by one system. It's great, it's very convenient, but it also creates some vulnerabilities, because if you know everything about it, well, if somebody gets in, they could know as well a lot of information about you. So it's very important to keep in mind that the more data that's available there, the more the vulnerability and the more the need to come up with schemes to handle privacy, security, data integrity, and all of those issues. And you'll see that now, in my view, any graduate from any program whatsoever should have some exposure to data to understand more. Like, we don't want everybody to be a data analyst or to be, deep learning experts. But it's important that every graduate understands what is data, what is the value of the data, and what are the challenges associated with the data and how to analyze it. So if you look at data in general, you'll see that everything, I talked about healthcare for a minute, but even now when we're talking about, let's say, applying the brake pedal when you're driving your car, I'll talk about transportation for a bit. So at the level of a car that's not even connected, no autonomous vehicles, nothing at all, we're talking about a simple car, low-end car that you buy nowadays, you'll find that even applying the brake pedal is a data analytics problem, because what's happening there, the signal goes to the computer, The computer says, I need to stop the car the fastest possible way. Let's look at the speed of the car. Let's look at the speed of each wheel to determine whether the car is skidding or not. Let's look at the direction of the steering wheel, the direction of the car. Let's look at the weather condition. Let's look at all of those, and then let's make the best decision to stop the car. So this is an AI or data analytics problem. However, in that type of problem, time is of essence, because if you come up with the absolute best way of stopping the car, but you come up with that solution 2 seconds from now, well, that's post-mortem for an accident. But you need to stop the car immediately, so then time becomes more valuable than how good the algorithm is. If you're looking at another problem, let's say a problem of epidemiology, for example, well, if you wait for a few minutes, that's still okay. If you wait for an hour, it may still be okay, and then you make the right decision. So when we're talking about algorithms and methods to analyze the data, it's important to understand the context, how important the real-time aspect is, and then come up with the right approach to solve the problem. So when it comes to transportation, I said that even within one car, you still have a lot of data analytics and lots of AI that's happening with respect to the brakes, the transmission, the everything, if you will, the engine, even like exhaust systems and how to handle all of those. So even within a simple car, if you're talking about a hybrid car, it becomes even more. And then we're talking about how the car interacts with traffic signals and so on. Then we're talking about connected cars, how the cars are connected to each other and talking to each other. So the problem becomes a lot bigger. But at the end of the day, doing the right analysis and saving the data the right way, transporting the data the right way, will definitely make a huge difference in our lives. So now I'll invite Professor Frank Dana to come and talk to us a bit more about the various programs that we have here that deal with data in one way or the other. So thank you. And
Hello, everybody. Thank you for being here. My name is Frank Dehne. I'm the director of our Institute for Data Science. The Institute started a little bit more than 5 years ago with generous support from IBM for a startup funding, and has been very active since. And this is our 5th Data Day here by now that we're organizing. And as you can see, data science at Carleton is growing in leaps and bounds, and there's so many people by now involved. The particular way Carleton looks at data science is as a big interdisciplinary exercise. So we really want to emphasize that data science is all about different disciplines working together. And so therefore, actually, the first and so far largest graduate program in data science that we started was the Interdisciplinary Master in Data Science, which by now spans 10 different departments. So in those departments, you have technical departments like computer engineering, computer science, and you have what we call the application areas, where in this program is involved School of Business, School of Economics, Geography, Biology, many other departments crossing all faculties. So in addition to those 10, actually, it's an ongoing exercise. There are new departments looking at joining as we speak. For example, public policy. And as Rafiq Gubran so eloquently explained, you know, there's so many problems that deal with data analytics in so many different fields. So students that go into our program can enter from those different departments. You know, if you're a business student, you can enter the data science program as a business graduate student. And so the admission criteria and everything, even the programs are different depending on where you come from, right? I mean, somebody who is a business student would get a different set of courses compared to somebody who's a computer science student in this graduate program. So it's a rather large exercise that we're running there, but it's very successful. At the moment, we have 80 graduate students in that program, which is a large number for a graduate program in its third year. And it's only 80 because we're capping it, because we just don't have more resources. And Carleton University is being great with supporting data science and making huge investments. So in many of the departments I mentioned, faculty have been hired, for example, in engineering, in business, in biology, in geology, in economics. New faculty members have been hired who work in data science. And actually, we have 5 new hires explicitly for the Institute of Data Science who work in data science. And so, and the Institute actually this summer is now moving into its own space. We're having our whole, like part of a building now, so that data science will have a home starting this fall. So that will facilitate people working together. So for example, for data science graduate students, as of this fall, there will be now a joint lab where people actually sit together and work. Right now, we're still distributed all over campus. The Institute is also very active in connecting people across campus from different disciplines, and both at the professor's level and at the graduate student level. For the graduate students, one of the best-known courses is the famous Data 5000 course, which every student in the data science program has to take, regardless which field you come from. And that's a project course that's organized such that each project has some people from a technical field and some people from an application field working together. Because really, at the end of the day, if you look at industrial settings, that's what it's mainly about. For example, people with a business background working together with people with a computer science background, solving problems together, learning how to talk to each other, learning how to collaborate, and bringing their knowledge together. In addition to the programs I mentioned, there's also now various undergraduate programs that have been started in data science. So for example, in engineering, there is a new undergraduate program in data science. In computer science, there is this a new undergraduate program called the Shopify stream. It is an undergraduate program in collaboration with Shopify that is particularly targeted towards data analytics in that context. And the cool thing is that admission actually goes together with an interview at Shopify, and students entering the program have a job at admission and carry that job through the program, through summer jobs, into employment when they graduate. There are other new programs coming online. There is a more technical master in data science that we work on as we speak, which will be sent into the approval process soon, which is a more deep technical collaboration between computer science, computer engineering, and mathematics, focusing a lot on AI and deep learning. And then there's also in the making a PhD in data science. So all these different programs will vastly increase the number of graduates in data science coming out of this institution. And as I said, as compared to other universities in Ontario, our focus is on the interdisciplinarity, on making sure that all the students we graduate have the ability to work together with people from other fields. And you see that in the success of the students we have at the moment. Due to the rescheduling, actually, many of them who have graduated already now, usually we would have this event a little bit earlier when they just are about to graduate, but most of them already have a job, and they're actually usually employed way before they graduate. So And as I said, the number of students so far is only kept by the resources, but we plan over the next few years to at least double that. And with this, I hand back to John.
So we're very proud of the development of our data science offerings. And as Frank mentioned, we have a collaborative Masters in Data Science, which is an annual cohort of 40 students. So right now there are 80 students involved in our data science master's program, and that's nothing going to do but expand that enormously. I'd want to move now into the sessions. So what we've done is put together 3 sessions during the day, one addressing the thing that affects us all, and that's what I call e-commerce or e-everything. And it's Blair, are you here? The moderator is somewhere around. That those members of that panel might want to come forward. We'll take a slight pause while I get organized, and then the next session will be on AI, machine learning, and activities. And then the afternoon one is kind of interesting because more and more we hear about, is this data useful, is it private, what am I going to do? So we have a session, and is it regulated? So we have a session more on that side this afternoon, which is probably going to be the most important aspect that we all have to deal with. So that if you just take a moment to get the panel going, you would, and those are sitting at the back, there are some seats here at the front. You don't have to pretend you're at the back there. There's some seats available around. So you'll just take a minute till you get yourselves organized, and we'll get the panel going. The panel members, please come forward. I'm saved, the moderator has arrived. When this building was designed, as you can see, the building had to be held up. That's why these 2 great concrete columns here. So it might be a bit awkward for some of you to see the screen, so feel free to move around. We haven't yet invented invisible concrete, so you'll just have to work around it. I apologize, but that's just a design fault. The space up at the front here. Yeah, that's all right. To all speakers, be careful if you lean on this. Otherwise, you're going to go for a flight. Okay, over to you.
Well, welcome everybody, and thank you so much for having us here today. My name's Blair Padaker. I'm the Vice President of Global Expansion at Invest Ottawa. And most of you know Invest Ottawa from the startup point of view in accelerating and incubating companies. And then the side that I work on is taking companies to the world as they're ready to export and going into Asia Pacific, pretty much all of Europe and all the Americas, or doing foreign direct investment. You might have heard of a little company called Amazon that we went after. some news lately in the paper on that, but that's the kind of stuff that we do, and then something called business retention expansion. My team also does a lot of sector profiling, including things like we're talking about today, going and aligning industry, government, and academia together to figure out where we're going, how we're getting there, and all those kind of great things. So today's panel discussion really about big data, what's happening, where we're going, how we're going to go after all that. And we have a great lineup of speakers. I won't go through everybody right now, but without further delay, I'd like to introduce Cameron Davidson-Pilon, Director of Decision Sciences for Shopify. And if he can come forward, he's going to do a 30-minute presentation, then I'll introduce you a little bit more to the rest of the panelists that are sitting up here. So without delay, if you could come on up and give us a talk. Thanks so much.
Hey everyone, hey, can you hear me? Okay, great, cool. So I'm actually going to diverge just a little bit. I wanted to do a presentation on e-commerce, but then I have this worm in my head, this idea in my head, and I really want to talk about it, so I'm going to diverge a little bit. John, I hope that's okay. Panelists, I hope that's okay. I think you'll find it very enjoyable too. So the story is, are my slides working? If I click, yeah. A little bit of help there, but I can start with the story. So about 9 months ago, I was on Twitter and I saw a post about the gender pay gap and the right way to analyze the gender pay gap and the wrong way to analyze the gender pay gap. And it led me to a book, and if my slides work. Anyways, the book is called Mastering Metrics. Here we are. Great, thank you. And the title is super cheesy, and I cringe every time I have to talk about this book. Mastering Metrics is just so, It's short for Mastering Econometrics, but this book is great. It introduced me to ideas around causal inference and instrumental variables, and the classical problems that economists have been working on for 40 years, and because of that, they've developed techniques. They know the limitations and the benefits of using observational data. So 9 months ago, I had this shift when I read this book, this shift in how I do analysis, and that shift is only magnified. But I feel like that shift has been more of a personal journey, and the rest of the data science community hasn't really done that shift, or at least it's much slower than what else is going on. So with that being said, I want to talk about what I consider the 3 pillars of data science. So the first pillar is, if you can read that says description. And I apologize for that. So description is, it could be as simple as taking a mean or an average or a median. It could be a conversion rate over time. It could be something more advanced like a unsupervised clustering algorithm. Basically, it's some way to describe the data. This is by far the most commonly used pillar in industry for data scientists working in industry. The next pillar is prediction, and that says prediction. And prediction is by far the most commonly talked about pillar of data science. It's at a high level, it's when you have some input variables and some output, and you want to map your input to your output, hopefully such that this new function can take a unseen output value or unseen value and map it to an appropriate response. That's the idea behind prediction. The majority of what the industry and community talks about is prediction. Maybe I'll digress for a moment and talk about all the tools that have been developed for prediction. These are just the most popular ones, but there's a long tail of less popular ones. We have this glut of technologies that do prediction, and they do prediction really, really well, but we spend a lot of our time focused on that. In fact, we almost spend, I would say, too much time focused on the technologies and the algorithms. Just like how an astrophysicist is defined by studying stars and solar systems, not someone who's defined by using a spectrometer. I want to consider, hopefully this works, great. Similarly, data science is the discipline that describes and predicts, not the discipline that uses machine learning algorithms. Let's define ourselves by what we're actually trying to accomplish, not the tools we use to accomplish that. Okay, so that's skipped ahead. So description, prediction are the two. The final one is what I want to consider as the third pillar is causal inference. And this relates back to the book on mastering metrics. So what is causal inference? It's understanding the relationships between variables. So here's some cause, or here's two variables. What's their relationship? Is there any association? If so, is it positive? Is it negative associations? We spend a lot of time, surprisingly, not talking about this. We sort of, I see very few articles or very few presentations on causal inference, and this is quite surprising because, in my opinion, it's the third pillar of data science. So if I were to extend my definition of a data scientist, it would be, so data science is a discipline that describes, predicts, and makes causal inferences, not the discipline that uses machine learning algorithms. So let's define ourselves by what we're trying to accomplish. How we get there, not so important. Or what technologies we use, not so important. So why do I consider causal inference really important? And I'll describe an example where if we had used, say, the other two pillars, we would have got the wrong answer. So about or a few decades ago, some researchers noticed that there was this this outlier, or this strange behavior in infant mortality rates. So here's a graph of infant mortality rate. The solid line is smokers, and the dotted line is non-smokers. This is the maternal smoking. The babies aren't smoking yet. It's maternal smoking. And so you can see that and this is also conditioned on the birth weight. So for birth weights above like 2,500, you can see that non-smokers have a lower infant mortality rate than smokers. But this interesting thing happens around 2,000. So babies that are born less than 2,000 grams, we actually see the reverse. We see the lines cross. We see that non-smokers have a lower infant mortality, or sorry, a higher infant mortality than smokers. And this was puzzling researchers. They didn't quite understand why. Some of them proposed that, maybe smoking is good for low birth weight infants. But that sounds crazy, and we kind of know that's crazy. There should be no situation where smoking is beneficial. It just seems like a purely negative thing. So this was known as the low birth weight paradox. Again, smoking is like a obviously bad thing, but imagine this was present for the diet of the mother, where diets, or sugars or fats, where it's less obvious if it's bad or good. So this is, again, maybe an artificial example, because we all know smoking is bad, but this could happen for any other data set. So the researchers, they observed this. And so if I look at my data set, I have an output of infant mortality, I have really nice observations, I have mother's age, I have other demographic details, I have other prenatal exposures like smoking and others. I have birth weight, so I have this great data set, lots of data. What I want to do with it is throw it into a prediction algorithm. So what the output might look like is something like this. So this is some naive decision tree. If birth weight is less than 2,000, try maternal smoking. That seems to work. Obviously, that's crazy. Like that's not really what's going on. But the algorithm can't really distinguish. The prediction algorithm isn't designed for understanding the causal relationships. It's just going to spit out what maximizes its prediction and or its output accuracy, and that makes sense. It's designed to do that and does that really, really well. You might think this is too simple, using a naive decision tree. Instead, we could use like a random forest model, which has like a measure of feature importance. If I did that, the output might look like this. So we can see that birth weight is a high importance for infant mortality. But again, it doesn't tell me anything about potential interventions, and that's kind of the crux of it. These prediction algorithms, they're agnostic to any kind of interventions we could do. They're really good at accuracy and other measures, but they don't tell us anything about the potential interventions. Okay, so I take off my prediction hat, I put on my causal inference hat, and how might I analyze this problem differently now? So we think there's this causal relationship between the variables. Maternal smoking, that influences mortality. It also influences low birth weight. Low birth weight also influences mortality. There's these additional confounders between maternal smoking and mortality. Those can be ignored for this analysis, but keep those in mind. So if I presented this to a bunch of domain experts who work in in medical research, they would say it's a too simple diagram. There's things missing from this diagram, and that's the crux of the problem. If I include, or I would present this, and they would say there's additional covariates we're missing, and that might be something like a birth defect. Unfortunately, that could be unobserved from my initial data set. But something interesting happens now. Something interesting is going on. Because I have this unobserved variable, and again, the prediction algorithm, it couldn't tell me about that I was missing something. But now, when I have this unobserved birth defect variable, something interesting is going to happen. So let's do this step by step. Okay, so I condition on low birth weight. You can think of it in your head. I've taken all the low birth weight infants and just sort of mentally hold them. And then if I know the parent didn't smoke, so let's assume that for a second, then the infant must have had a birth defect, therefore higher risk of mortality. So what that means is that I've now introduced, whereas there was no association before, I've now introduced an association between smoking and a birth defect. There's no association a priori, that's my assumption. But because of this, I've introduced an association. If I know this, it's not this. In fact, furthermore, it's actually a negative association. I've introduced a negative association between low birth weight and smoking and birth defects. So if you go one more step, I've introduced a negative association between smoking and mortality. So if you smoke, you might have low mortality, which is like crazy and interesting, but that resolves the low birth weight paradox. What's happening is we shouldn't really be conditioning on low birth weight. It happens on the causal path. If I go back one slide, 4 slides, it happens on the causal path. So maternal smoking influences low birth weight, which influences mortality. So yeah, just think about this for a moment. This is actually really, really important. Our prediction algorithm couldn't have told us anything about unobserved variables. It would have used low birth weight as like a high predictor or high feature in our decision, our classification. But if we ignored that and just looked at, or if we didn't consider that and just looked at the causal network, we would see we've introduced bias into our calculation. So I think this is really interesting. It's a case where naively we would have made a mistake if we had used prediction algorithms, but we needed causal inference to sort of understand the network better. And so what does this mean for, say, teaching data science? I work with some students from Northwestern University, just outside Chicago, and they're bright students. They're masters of data science, and I asked them if you're taking a causal inference course or anything related to that, and it was kind of the first time they had heard of it too, and it relates back to my story. Like, what took me so long to sort of hear about the importance of causal inference? I really related it back to that book I read, the Mastering Metrics book. But maybe I was unique and I missed all the kind of paths that would led me to causal inference, but I think it's actually more of a widespread problem with the data science community. We're not talking enough about this particular technique or this particular pillar of data science. I think one highlight, though, is that economists have been working with observational data for a long time, and for 40, 50 years, and they kind of understand these causal networks better than most data scientists do, really. So if there's one thing I'd want us to take away, and it was great hearing this morning that Carleton's already doing this with their data science programs, is I think we should be thinking more like econometricians. Economics might be a stretch. I don't need to know much about supply-demand, but econometricians, they're the ones who are deep in the data. They're discovering techniques like instrumental variables and RDD designs and stuff like that. So that's one thing I want us to all take away. I think there's lots of value in understanding causal inference, and one way to do that is to think more like an econometrician. A great start is that poorly titled Mastering Metrics book. Great, that's all I have. I'm around later today if you want to chat more about this. I'm very passionate about this. Like I said, I've done this shift about 9 months ago, and I'm thinking more and more about this recently. So thank you. Yeah, I can take a few questions now if you'd like, if there are any. Please.
And then, so I guess my question for you is, how do you have that conversation with people who don't necessarily have a background in understanding causal inference, having the conversation about who gets to do the machine learning or who's responsible for using those tools, and I don't know, just having that conversation with the background knowledge required, and how do we think of data scientists as, not using tools, but what you were saying before about, yeah.
Yeah. So one of the skill sets that a data scientist should have is like software engineering or just some sort of programming. So I do expect them to be implementing the algorithm. However, I shouldn't have said algorithm. However, like data scientists should more or less be depending on existing packages to do most of that heavy lifting. Again, that's just a tool that we use. The ultimate outcome is prediction. Like, how can you make your prediction better? How can you build ensembles on top of that? How can you diagnose a machine learning model? Like, how do you know the ins and outs of it? That I think a software engineer wouldn't possess because they don't understand that level of detail in the algorithm, or they don't understand what they're actually trying to accomplish, i.e. prediction. So I think it's quite clear. I don't think software engineers, unless they're really trying to scale something, should be doing a lot of machine learning. It should come down to the data scientist. Does that answer your question? I got a maybe. Okay. At the mic, sorry.
Hi, thank you for bringing that topic up. It's something I've thought about a lot too. In the whole discussion though, I didn't hear you mention the word statistics or statisticians once. Statisticians have been studying causal inference for 100 years.
Yes.
What role do you think that has to play in how
Fair.
a data scientist does his job?
I didn't mention that at all. Mostly because I have trouble saying the word statistics. No, I'm joking. Yes, they have, and I think that's part of causal inference. Like statistics sort of underlies both description, or all three: description, prediction, and causal inference. I think if I thought about kind of who exemplifies causal inference, it feels to me like it's economists, because they're working with like real life, or econometricians. They're working with like real life data. They're using techniques from statistics to sort of diagnose, or sorry, not diagnose, to understand the systems. I mean, actually, a better example might be biostatisticians and epidemiologists who are working like really hard around this topic as well. So I apologize to any statisticians in the room. My background is stats. I just assumed that we were all talking about that.
Okay, that's very interesting. I mean, but I consider that maybe it's more like the scientific method per se. So when you look at the scientific method, you try to analyze the cause and effect and all those alternate. Then you start with an hypothesis and try to find if they are counter to these hypotheses to make sure that you have the right path or dominant path toward the what you have observed. So I will say, I know that you said it is a simplified way to look at the problem, but sometimes we have to work around the problem and investigate what are the alternatives. And this is simply the scientific method to me.
I agree. That's a great point. I would also say that maybe data scientists aren't always trained in the scientific method. Maybe that's part of the causal inference course that should be included, or some articles or whatever about causal inference. If I had given that naive low birth weight data set to a data scientist, they may have not come to that conclusion that I should be thinking about this from a scientific method perspective. They might first go for their machine learning algorithm technique.
Thank you.
Thank you. Good question. Yes.
My comment has more or less been answered, but addressed. But let me just say, as a PhD fallen economist and a professor of epidemiology and working at StatCan, epidemiology I prefer to economists. Economists are very fond of making a whole bunch of assumptions that have no empirical foundation before they derive their specifications. And
Shots thrown. Okay, yeah.
whereas epidemiologists are, I have to say, a little more open-minded when they try to do their causal inference. And for everybody, Epi 101 is one of the first things you'll learn is correlation is not causation.
That's great. That's awesome here. I mean, a lot of this came from epidemiology. A lot of the researchers come from epidemiology, their backgrounds. My first thought was econometricians, only because the Mastering Metrics book kind of introduced me to it. But that's led me down the path that epidemiologists took about 20 years ago.
Are there any more questions before? Oh, one, two. Okay, hold on just a second. I'll get this. Go ahead, sir, and then we'll go to you. Go ahead.
Okay. I gather that many people might arrive at data science from different backgrounds. So I'm curious how much you think we can expect to be learning topics like you brought up on the job versus in an academic setting.
It depends on, I think, your environment, like who you're working with. Hopefully, like your team has a background in these kind of different flavors of data science. Like some are really good at descriptive stats, some are really good at prediction algorithms, and some are really good at sort of causal understanding. I think, like I said in my presentation, that most of data scientists working in industry work with like descriptive stats. Like that's a very common thing. So that's the most on-the-job learning probably potential. I think causal inference is the least, just because it's not talked about much, and most data scientists don't consider it a pillar, or they're not like using it as often as the other two. So I would go, description, and then prediction, and then causal inference in terms of like what you can learn in the industry. If you're working in the industry, if you're working at like a hospital, it might be inverted.
Hello. My question is over here.
Yeah. Hey.
Thank you very much. I never thought about data science the way you kind of described it. I kind of read that book as well, Mastering Metrics. And the returns to education is like the classic econometrics problem. And how does that apply to e-commerce, since you're director of decisions at Shopify? So I'm just more curious of what are some of the problems that you have to go through with the data. So obviously you have to do some feature extractions and stuff, but I'm not very familiar with the type of e-commerce data would be at Shopify.
Sure. So one recent example was, I could phrase it as the returns to latency. So we have hundreds of servers, and we have visitors from all around the world, and there's a latency between a visitor and a server, depending on how far away you are, plus your connection and such. And the question was, how much does latency affect overall conversion, or overall like sales that the visitor might make? So we can think there's like a return to latency, and that can be defined in sort of a causal inference problem, where I have lots and lots of observational data. I have like appropriate controls, and I can look for what's the effect of latency on overall conversion, and that can drive decisions around: should we invest more in servers and global servers? Should we invest in faster loading speeds, stuff like that? That's one example.
I think we have time for one more question.
I'd like to ask if you've ever heard the story about the man who plotted deaths in London some years ago and identified the fact that the deaths were concentrated around a well, and this well carried a disease which killed these people.
Yeah, that was John Snow, right? Who discovered that?
My point is that this was how many hundred years ago? Don't you think your point is that people should have a basic education and learn things? A
Sure.
fundamental understanding. It doesn't come from processing data. Newton, Galileo, all of these people, the scientific method, this is pure, simple, intelligent behavior on the part of people.
Yeah, I totally agree. So I guess like, what's our role in this? I think we should be educating people to maybe think this way more frequently than they already are. The low birth weight paradox, that was a paradox only because the initial researchers didn't think enough about it. And I think that's an interesting story where it's easy to take a data set, crunch some numbers, and spit out a result, but you have to sort of think more about it, i.e. the scientific method, or think about the causal networks, and that helps you come to the right conclusion, and not a disastrous conclusion, which could have been having mothers smoke, which is crazy. But I mean, this happens, I mean, epidemiologists, they've seen cases where there wasn't enough understanding of the system, and we made the wrong conclusion using stats and observed data, and it did harm people in the end. Okay, on a lighter note, I'll be around afterwards.
Okay, great. Thanks so much, Cameron. Thank you, thank you. So that was great. Thank you very much. I never really thought of it in that perspective. Back in the day, my mom was a smoker. I'm not sure if this is a product of smoking, but it was a thing you did back then, and it's interesting, for sure. I think as we move into the world of deep data and figuring out what's going on, to the last gentleman's point, I mean, things have been around for forever, but now we have a unique opportunity to gather that information and spin it into what we need and to actually really find out what's going on. The rest of the day is going to be really interesting because you're going to get into some of this discussion about AI and a whole bunch of other things that are going to be happening. But I think the bottom line is the more we know, the more we can do for the human race and where we're going. And I know that sounds like a big lofty goal, but really at the end of the day, we can do things at a snap of a finger that took somebody 100 years ago to plot out over many, many years. There's advantage to that. There's power in doing that. And I think that's the point moving forward. The question is, how are we going to harness this and how do we keep an eye on it so it doesn't overtake everything that we do? You had me at hello, by the way, and you lost me on stats. I'm not a stat guy, but I'm a consumer of all of this information. And that's who you're appealing to. You're appealing to guys and women like me that are going to take this information and learn more about the world that they live in and what's happening and all that kind of great stuff. So I'm just teeing this up a little bit because we have 3 panelists here, and I'm going to start introducing them one by one. They're all going to have 10 minutes to talk a little bit about themselves. Hugh Carnes, SAS and Sprott School of Business. Hugh has experienced data science with over a decade of experience in working in several industries such as federal government, healthcare, transportation, logistics, financial services, telecommunications. He's been with SAS Canada Professional Services team for the past 10 years. He's a senior director of science with SAS Canada. He's worked also with the Public Health, Ontario Ministry of Labour, Canadian Correctional Services, Passport Canada, Canada Post, Rogers Communications, and the list goes on. And dealing with your data every single day and where it's going and how they're using it. And that's super important because this is your personal information, folks. So we're going to start with Hugh, and we're going to go into the next 2 panelists, and we're going to have a discussion with the 3 of them. So give our guest a warm applause here. Thank you.
Thank you very much. Thanks for having me today. Like our moderator said, my name is Hugh Cairn. I'm a senior data scientist with SAS Institute Canada. I'm also a PhD student at Sprott, and I teach one of the data analytics courses. When I started my journey down in this, it was about 15 years ago. I've been working with SAS for 10, but about 15 years ago, I was known as a statistical programmer. And then I was known as a data analyst, and then I was known as a data miner, and now I'm a data scientist. So I do pretty much the same sort of things for the past 15 years, but the name's getting a little bit sexier. The problem is my wife still doesn't know what I do on a day-to-day basis. So that doesn't help that. Hopefully the next name kind of will describe that a bit better. I'm just going to wait. I'm going to spend just a few minutes to introduce SAS and then introduce kind of what we do and how that impacts or how we're using that in e-commerce. SAS Canada, like we said, SAS Canada has been doing, SAS Institute out of Cary, North Carolina, is the largest privately owned software company in the world. We're owned by a gentleman by the name of Dr. Goodnight. And we've been doing this for about 50 years. So although everybody may think this is a new fad and data science is just taking traction, it's been going on a long time, but there's been some fundamental things that have enabled us to move to the forefront. And one was the digitalization of computer ICT transmission. When it was analog, it was very, very difficult to capture that data. Now that it's digitized, we can capture it, store it, and analyze it. So that's probably the first reason. There's also Moore's Law and the increase in the computational ability. When I first started, I started with Bell Canada, and a big data set was about 15,000, 20,000 records. If you had something at 100,000 records, you pushed the button and went for coffee. If you had something over 200,000, you pushed it right before you left for work, and you hope your code didn't have any errors in it by the time you came in the next day. So there's reasons that data science is now, everybody's talking about it. So the SAS Institute Canada, we have about 300 employees. We've been doing this for about 40 years. Dr. Goodnight owns it. He's doing very well. We usually have sales of about $3.5, $3.6 billion a year. We're in 150 different countries. We're installed, our install base, and we are 94 out of the Fortune 100 companies. So what SAS is a software programming packages that contains all these algorithms for advanced analytics. So we're talking predictive modeling, forecasting, optimization. We've been doing AI or neural nets, things along that lines. And we also have a data management component. What we do with that, we solve a lot of different business problems with that. So I grew up and cut my teeth on marketing analytics, so really understanding what the customer is doing, doing models on who's going to leave, who's going to join, who's going to cross-sell. And we're talking about statistical modeling, such as logistical regression, decision trees, things along that lines. We also have a big space right now in cybersecurity, so we're using, again, the same analytical techniques that we're using for customer insight. We're trying to figure out which machines on a network have been infected, who are behaving differently. So we're doing it as we did consumer behavior, and understanding consumer behavior from the data. We're actually understanding computer behavior through using the data as well. So we have that type of information. What I think is important with e-commerce and how we really fit into it is e-commerce produces a lot of data, and as a data scientist, that's what I need. So having that allows me to give the inputs to what I need to try to understand. Now, also with e-commerce, the transaction to switch, the switching costs to go to another site or another platform are so low that it becomes really imperative to understand what your customers are doing and your supply chain's doing as well. So we can bring to bear our supply chain analytics and customer analytics as well. And it becomes even more important on an e-commerce platform to understand what's going on. We can also, because we're accepting people onto our network to go buy our goods, we can put to bear our cybersecurity solution as well. So things like that are enhancing or accentuating the need for data scientists out there. Another reason, cybersecurity was the third reason, I'm sorry. So I don't have my slides up here, so I'm going to kind of wing it. Now, I was thinking about e-commerce and the analytics space and trying to kind of come up and encapsulate how it's used and how important it is. And before I had children, I had some disposable income, and I like to dream about those days once in a while, late at night when I think I have money. And I was looking for a fishing canoe. And I was just poking around the internet, and I could buy a fishing canoe on Amazon and have it delivered the next day. And I'm not talking a little fishing canoe, it was a 16-foot fishing canoe. So I was thinking about the analytics that were involved, the amount of data analysis that was involved to guarantee me a 16-foot canoe the next day. So when you think about how much data was analyzed in terms of logistics, IoT, all their supply chains, their deliveries, things along this lines, it becomes very, very impressive indeed. So here's SAS, sorry, I've already gone through that, I'm not going to. So this is the Forrester Wave, and it basically ranks analytic platforms on strengths, and as you can, we're in the very, very top right. So we're one of the stronger ones. We've been doing this for 50 years. So we have data management, customer marketing insight, fraud compliance, and AML. We do a lot of work in the fraud space. So that's another important methodology and analytic problem when it comes to e-commerce. Is the person coming in a fraudulent, or some sort of compliance? We have cybersecurity, health analytics, risk optimization, forecasting, and we have some BI, and we do a lot of unstructured data as well. Text, that's where so I've already talked about the digitalization of the commercial transaction. E-commerce sites and online retailers require near real time. So I think in the next 5 to 10 years, how my job's going to change. Now I have a bit of lag time, and times I pull in the data, I make my model, be it decision tree, logistical regression, neural network. I come out, I produce some scoring code. I have some time to do that. In the future, with so much of the commercial activity being online, we're not going to have very much time to do that. You're going to be deploying models. You're going to be scoring hundreds of millions of records every few minutes. And we have the ability to do that right now with our event stream processing and our cybersecurity solution. I create a logistical regression model, and I deploy it, and we score about 1 million to 1.5 million records every 2 minutes to see if there's any machines or devices on the network that are giving us trouble. Analytics can really be seen as the driver for automation of your supply chain. We now have the ability to automate, push a lot of those decisions out onto the computers and out onto your network and your supply chain to make those decisions quickly. And yeah, that's where I got most of those. So SaaS analytics for e-commerce, we have marketing analytics, supply chain analytics. A big one's coming is sensor and IoT, demand-driven optimization. We also have web analytics, so how people enter your website, where their clicks are, where they have the most propensity to buy. Do they like red letters or blue letters? Text analytics and sentiment analysis, pricing, market baskets. So we have a retail solution that looks at the correlations of what you buy and the correlations and helps you price, fraud, and cybersecurity. And I think that's it.
Okay, great. Thanks so much. We'll hold for questions after, because we're going to have a conversation with these folks. The next speaker is Ed Finn from Napkin. He's pitch hitting for Hollis Bowman, who unfortunately couldn't be here today. So she sends her regrets, and Ed's going to come up in a second. His passion is turning data into knowledge. As a leader of Napkin's analytic team, he's partnered with large e-commerce business in North America to help overcome insights, understand performance, drive new value through advanced digital analysis techniques. So a big warm welcome for Ed to come on up. Thanks so much.
Let's see if we can get these slides up here. So, full disclosure, I was short notice, so a lot of these are recycled from other presentations. So I'll kind of start with the obvious stuff while the slides get up there. Oh, not that one. So Napkin specifically specializes in web measurement. So the vast majority of my experience, I have studied econometrics, and I do have a pregnant wife, by the way, so that was a weird presentation. The vast majority of my experience is going to be working with online data sets, so probably a subset of what Hugh was talking about, marketing analytics, online marketing analytics, e-commerce, stuff like that. And so what's Napkin? I'm just going to run through kind of what the company is and what I do specifically, so you understand my perspectives, and then I'll be very clear about what my opinions on big data and societal change are. So Napkin specializes in web measurement. We work with a lot of big retailers. We work with a lot of big enterprises. And let's just make this easy and do an example. So if Carleton University needs to understand how people interact with them online, we have to do a lot of work. So for example, just before we got up here, I went on the Sprott website, and I went on the Carleton main website, and they have different web properties. So they're already categorizing their data 2 different places for 2 different subsets of the business. okay? So I have to talk to arbitrarily 20 different departments who have different goals, they have different purposes for their websites, they have services that they provide through software that their employees use, they have apps, they have all these different things. Each of those needs to be rolled out to meet the requirements of the individuals who are expected to hit those conversion points, or produce new enrollment, or get volunteers for events. All of those things need to be tracked. And then at the end, when the executive board is asking, how are all of my business units performing? How are all my departments performing? Those things need to roll up in such a way that the data architecture is not nonsense when you look at the big picture. And that's just kind of an example of what I do with a lot of companies. The analyst team specifically is different in my industry at Napkin. You probably already heard Cameron mention it, I believe, but a lot of people believe that an analyst should know how to program. We don't believe that. We tend to isolate for creative thinkers, divergent thinkers, and we leave the programming in the hands of other people. We focus on ensuring that someone who can be creative with numbers is just focusing on being creative with numbers, because the skill sets, in our experience, for development and coding don't always align with the skill sets for telling an interesting story, especially to an executive. Now, that's probably going to be a controversial statement. I can't wait for people to come after me for it. I worked at a startup. Napkin is no longer a startup, but web analyst, account manager, project manager. So I've seen a lot of this stuff. I'm not just speaking as somebody that dives in data. I have dealt with CEOs at Fortune 500 companies and had to explain to them why they couldn't have what they wanted, or explain to them why they needed to measure things differently, or why you needed to ask that question 6 months ago if you want the answer now, those kinds of things. And most of the industries I've been exposed to, again, tier 1 retailers, financial organizations, services industries. The financial ones, especially in the last 2 years, they're kind of all starting to knock on the doors for web measurement. So why don't companies just do it themselves? Some of them do. Most specifically, financial industry. So banks actually have pretty well-established data practices, in my experience. Big financial institutions, Deutsche Bank, Goldman Sachs, organizations like that. But a lot of organizations don't have a data method. They don't actually know where to start. And that's why we're kind of in the state that we're in now, where a lot of companies are tracking things. A lot of organizations, universities, nonprofits are tracking things, but they didn't start tracking a bunch of things on purpose. They just they opened the floodgates and they let all the data come in, and they said, we can be data-driven now, right? But that's not exactly how it works in my experience. The second reason is silos. A lot of, especially big organizations, will have inherent competition in internal departments. In my experience, marketing and the development team do not get along. And having an objective third party helps a lot to just objectively define what winning is and help everybody measure what does and doesn't work, instead of some people that are technical experts arguing with a bunch of people that are very touchy-feely with the consumer experience. Writing your own report card is the other one. So a lot of other vendors will write their own report cards. They give performance stats on how they're performing. And in general, we've been hired by a lot of marketing teams because they say, well, why would I let somebody tell me they're doing a great job? In my experience, nobody ever tells you they're doing a bad job. Most importantly, companies are willing to pay for expertise, so a lot of them don't want to start at the ground level and figure this out piece by piece by piece. They just want to hire a company that has done it, has proven they can do it, and we've got a good track record of doing that. Brass tacks, these are the things I believe, and these are the opinions I'll represent. So e-commerce and big data have changed society. They continue to change society. There's several trends in the industry that are being touted as real game changers that may have zero impact or tons of impact, but it's actually really hard to be certain. And in general, data-driven cultures suffer because they're not supported. A lot of data sets that have been collected in the last 20 years have been thrown out because nobody maintained them properly. That's my perspective based on my experience. And we're not doing questions, but there's a Big Lebowski quote, but there's also a picture of my cat, and I'll wrap it up there.
Well, thank you very much. Insightful, very good, thank you. And last but not least, Gustavo Frederico, ThinkWrap. He's a senior development lead at ThinkWrap in Canada. He's been working with enterprise software development for 2 decades, specialized in e-commerce for the past decade. I love this line. He's an admirer of computer science, and he just may be a secret admirer of social sciences. Take it away.
Thank you. Good morning. My name is Gustavo Frederico. Waiting for the presentation to come up. Thank you, Carleton, for hosting us. I'm a software architect with ThinkWrap Commerce at Tenzin Company. ThinkWrap is a company specialized in e-commerce service. Earlier this year, 3 companies merged together, ThinkWrap Commerce, Tenzin, and SparkRad. Now we are a team of approximately 230 employees with offices in North America and in Spain. This here. Let's see if we can get the presentation. Here we go. There you go. One of the applications of big data and e-commerce that we have been working on is a product recommender. While the universal recommender is independent of e-commerce platform, we tested it with Oracle ATG Web Commerce and SAP Hybris Commerce. The universal recommender models any number of product properties and user properties, as well as user actions in relation to products such as view product, add to cart, and purchase. Often in e-commerce, only a portion of product catalogs change frequently, like price and stock, while new shopper events appear gradually. One of the things that we would like to explore is reinforcement learning, trying to model deltas and events for better use of computational resources. And I have to say, Apache Mahut Samsara is good. One problem in e-commerce that may be common to other domains in machine learning is that of data modeling. While the universal recommender leverages product and user features, the data representation cannot leverage the inherent hierarchical property of product categories, for instance. Another challenge with data representation is that of base products versus variants. For example, a shirt can be a base product but the buying unit, or the SKU, may be a large green shirt. And products can also be configurable, like a hamburger. I'd like to list other functionality where big data machine learning can help e-commerce systems. Search results can be seen as the output of a recommender system. When APIs are exposed on the internet, hackers can try to steal login information or reward points or abuse of promotions. Machine learning can be used to detect malicious requests. This problem, in fact, is not specific to e-commerce. The approach can be used in microservices in general. Machine learning can also be used to better detect credit card fraud. Another challenge in e-commerce is the verification of product reviews. Detecting cart abandonment is another application of machine learning. In product information management, classification algorithms and NLP can automate product categorization, especially for large catalogs and B2B sites, integrating external vendor catalogs. Classification algorithms and NLP with sentiment analysis can help customer care with case tagging, case prioritization, and dispute resolution. A recent development in the area of e-commerce and legislation is the European Union General Data Protection Regulation. It is designed to protect data privacy of all European residents and requires website operators, among other requirements, to consider any applicable notice and consent requirements when collecting personal data from shoppers, for example, using cookies. GDPR, as it is known, not only applies to organizations located within Europe, but also applies to organizations located outside of Europe if they offer goods and services to European shoppers. It came into effect May 25th of this year, and it defines fines for non-compliance. GDPR, in my view, includes a bigger scope of rights and protections when compared to the Personal Information Protection and Electronic Documents Act that we currently have in Canada. Thanks to GDPR, for example, we know that PayPal shares personal data with more than 600 third-party organizations. Of particular interest to machine learning are the rights in relation to automated decision-making and profiling. Quoting Mr. Andrew Burt, quote, "The GDPR contains a blanket prohibition on the use of automated decision-making so long as that decision-making occurs without human intervention and produces significant effects on data subjects," end quote. One exception is when the user consents explicitly. One issue is the interpretation of what can be called rights to explainability, that is, rights to explain the algorithm, its model, and reason, considering machine learning algorithms and models can be difficult to explain. Yet another challenge is the right to erasure. Should a machine learning model be retrained after the user asks to delete her or his data? The Working Party 29, an official European group involved in drafting and interpreting the GDPR, understands that all processing that occurred before the withdrawal remains legal. However, a more critical view could argue that the model is still directly derived from the data and can even review the data itself with overfitting in some cases. The first international beauty contest judged by AI accepted submissions from more than 6,000 people from more than 100 countries. Out of 44 winners, nearly all were white women. In the United States, software to predict future criminality does exist, was found to be biased against African Americans. In these cases, as in many others, societal prejudices made their way into algorithms and models. Let's not forget that software systems are built in certain contexts and deployed into contexts. The International Beauty Contest reveals a naivete, as if software could reveal a culturally neutral and racially neutral conception of beauty. A coalition of human rights and technology groups at the RightsCon conference a few weeks ago drafted what is called the Toronto Declaration. RightsCon covered a broad list of important subjects related to AI and society. The Toronto Declaration emphasizes the risk of machine learning systems to, quote, intentionally or inadvertently discriminate against individuals or groups of people. It reads, intentional and inadvertent discriminatory inputs throughout the design, development, and use of machine learning systems create serious risks for human rights. Systems are, for the most part, developed, applied, and reviewed by actors which are largely based in particular countries and regions with limited input from diverse groups in terms of race, culture, gender, and socio-economic backgrounds. This can produce discriminatory results, end quote. Stanford's University 100-year study on artificial intelligence is a long-term investigation of AI and its influence in society. Section 3 of its latest report, called Prospects and Recommendations for Public Policy, calls to, quote, increase public and private funding for interdisciplinary studies of the societal impacts of AI. As a society, we are under-investing resources in research on the societal implications of AI technologies, end quote. Thinking of societal issues raised by AI and automation, I chose to quickly mention the issue of employment. One good article by Dr. Ewan Mokgogi, titled, Will Robots Automate Your Job Away? Full Employment, Basic Income, and Economic Democracy, argues that robots and automation are not a primary factor of unemployment. He writes, quote, once people can see and understand that institutions that shape their lives and vote in shaping them too, the robots will not automate your job away. There will be full employment, fair incomes, and a thriving economy democracy, end quote. My best friend is a professor of machine learning. He's a funny and at times even sarcastic person. One day he described to me a hypothetical conversation with a philosopher. When I submit applications for grants, I ask for hardware and software for my lab. What do you ask for? A chair? The philosopher, Thomas Kuhn, could have replied, new science gets accepted not because of the persuasive force of striking new evidence, but because old scientists die off and younger ones replace them. The endeavor of modeling and interpreting zeros and ones is epistemic and hermeneutic. The time is not for isolation, but for collaboration. More than ever, we need to encourage social sciences and the humanities to help us understand what to do, how we do it, and why we do it. Thank you.
Well, thank you very much, Gustavo. Back 10 years ago, I was the vice president of business development for a mobile solutions company. And part of my job was to go to the Valley, Palo Alto, and try and get money. And at the time, what we were arguing is that the enterprise solution stuff that we were doing really crossed over into the social realm and social media. And back then, if anybody was going down to the Valley trying to get money, you had to pick a track. Every time you talked to them, they would say, chicken or beef. You're one or the other, you're not both. 10 years later, that's gone. The lines are completely not drawn in the sand anymore. It bleeds over into each other. We were probably about 4 or 5 years ahead of the curve at the time. And had I stuck with it, I probably, maybe would have been Shopify, I don't know, but I probably would be doing something a little different. So the point being is, everything that we do every day is being driven by big data. It's when we wake up in our Fitbits in the morning and you know what my heart rate was all night, what my sleep pattern was, why I slept well, why I didn't sleep well. All this information's coming a mile a minute. And by the way, you're all driving it. You're driving what's happening out there. You're driving the content that they need. So big data is just the vehicle to get us there. But with big data and what's going on in the world right now, how do we harness this? I don't want to steal the thunder from some of our other panelists, but the reality is it's going into your personal lives every day, which is the social part of this. And do we harness this? Do we do things with it? There's going to be an AI conversation on robotics and all that kind of stuff. I personally met Sophia once down in Hong Kong, where she was created, if you know who she is. She's the robot, that's AI. And then I saw her not too long ago in Toronto, and she remembered who I was. She remembered my conversation. She remembered everything. It's a scary world. We're moving in that direction. In fact, I'll tell you a little story, and then we'll get to our panel. In my conversation with Sophia on this whole, and she's got tons of data in her head, right? She said to me, why don't you tell me one of your dreams and I'll analyze it. So I made one up because I didn't really want her to analyze my dream in case she was good at it. And I said, I was swimming in the ocean. There was a shark behind me about to attack me. And she said, you have repressed feelings of your mother and father and you need to get some help for that. I thought, super, awesome. So she remembers me. The world's changing, right? These things are happening like that. And these folks are making it happen. So I guess my first question to anybody, I'll throw it out to maybe Ed, because you deal with companies all the time. What's our biggest hurdle that we're going to go through in big data? I mean, we know the normal stuff, gathering information, making sure we're doing the right thing with it, safeguarding GDPR. I mean, you contravene that, you're going to get major fines. That's the bottom line on what you're talking about. But what do you think some of the big things are we got to watch out for? No, you do have. I think everybody's got a mic, right? Okay, good. Go.
Everybody hear me? Okay. So I think that. I'll make one of my points again, which is GDPR may or may not have the level of impact that we're seeing it, where people are predicting it will have. It needs to be proven in court. And unless I'm mistaken, I don't think anybody up here has a law degree. So it may or it may not. Right now, marrying data sets in a consistent way, and so kind of on-purpose data architecture is the most important thing I see happening right now. More and more companies, even ones that have been sophisticated about the way they track things online, are going, oh crap, we should have thought about marrying this to our CRM system sooner. We should have thought about making this available to our data science team sooner. And that's the kind of growth I see. The marriage of data sets, gluing APIs together, that's for companies that are already at least tracking things and treating data properly, that's the biggest growth point I see right now. You?
Well, with the release of GDPR 2 weeks ago, there was another news point that, as a data scientist, I was very interested in. And it was the ACLU in the US asking Amazon not to sell their facial recognition solution to police forces. And now you may ask, why, as a data scientist? Data integration is still the toughest part. So if you use a fake name on Twitter or social media, I can't marry that to my internal database. I could do some fuzzy logic and maybe get it right some of the time. But with all this facial recognition software, that's a no-brainer. If I can get faces, and I just have to know who one of the faces are, I can then match that up. That's my data integration point. Because I could take a picture of somebody and I could recognize that same person if they posted a picture on Facebook or somewhere in the internet, and now I have my integration point. And now there's no privacy. Right now you can kind of hide with your different names and your usernames and things like that. But if we get the ability to accurately pick people out of pictures and things like that, I can integrate all the data, which is scary to me exciting as a data scientist, terrifying as a citizen. So,
Gustavo, do you want to jump in?
I just add, I think that GDPR is an evolution of these conversations within society, meaning as citizens, as shoppers, people want to have basic protections and basic guarantees of how their data is going to be used. So I think I have a very positive view of the kinds of protections that GDPR gives to shoppers and citizens. On all the consent has to be granular and explicit. The right to erasure of data. I think those are basic guarantees that there are asks of society at large that I think technically there is no difficulty implementing them. I think they are reasonable requests by society at large.
We have a token company with us, Shopify. Are you guys watching this?
Yeah, very, very closely. And one thing I want to mention on GDPR is I think it's a great step. I think the cost of data analytics and machine learning is often too low. It's too easy to acquire data and do perhaps incorrect things with it. There needs to be a higher cost to doing machine learning, and GDPR is a step in that direction. So at Shopify, we've done like a lot of work in the past year or so to make sure our systems are GDPR compliant. We had like a privacy summit a few months ago to discuss the evolution of how we work with data and how we sort of respect our customers' data.
So we're already talking about 62% of smartphone users are doing online purchases and doing all this kind of stuff. And I'm switching away a little bit from the regulatory stuff. I think that's coming a little later on, John, so we won't go into that too much more. But our phones are driving everything, like our devices. They're getting smaller. You don't need 10, you got one. I remember when I was at Diefenbunker, I don't know if anybody's been there, I brought my kids. We walked into the war room where the computers are, and the first thing they said, in addition to, what's that? And it was a rotary phone. The guy talking to us said, all these computers, there's more technology in your little smartphone, like hundreds of times more than in all this room to run the whole country underground. This is 34 or 50 years ago. So fast forward today, we can put everything on something this big these days. Is this going to be an issue, like pushing data and getting all that done? You guys deal with big data all the time. You're in the consumer retail business online. I mean, this is going to be a problem, is it not, at some point? Or are we looking at that down the road, being big data people? Are we going back with that again?
Yeah, I'll go for it. I think it just represents a huge, like the opportunity is so much closer for companies now than it would have been 100 years ago. So like staying on the economics theme, solo paradox, like one of the pieces of technology where people were like, why the hell isn't this increasing productive capacity, was the fax machine. And it's the one they always bring up in economics classes as an example. Because if you own the only fax machine, your fax machine is useless. And the more fax machines that are in the market, the better off you are. So if you're coming up with any kind of mobile solution, like we're in Ottawa, Uber took over the taxi industry very quickly. So I think the biggest difference of everybody having smartphones is that the network effect is there. You just need a way to leverage it.
Okay.
Well, I see smartphones as kind of like temporary. They're kind of this intermediate device. One sort of step I loved recently was Apple's new AirPods, I think they're called. And that's basically a little computer in your ear. Eventually, that'll be agnostic to even having a smartphone. And Apple can now, and you can communicate to Apple via Siri. And it's all just now inside your ear. I think it's a headphone right now, but in the future, it's going to be that actual device that you talk to. So smartphones is just one thing, but then AirPods, and then contact lenses. Who knows? But I think it's getting more and more subtle as we go, which is interesting, and I think it's awesome.
But while we're on the subject, just for 2 seconds of Shopify and what you're doing, so right now you're setting the trend, like Amazon and all these big companies. We probably have a lot of young companies that are in here trying to become you. What's your advice a little bit on how to get there? What's going on? Like, what do you need to do to kind of get there? And I'm not talking get venture capital and that sort of thing. I'm talking about what we're talking here today in terms of data analytics and understanding that.
My advice would be, sort of start from first principles, like build your data warehouse that can store all your data and can scale it really well. From there, move into more reporting analytics. From there, move into more experimental design and like A/B testing. From there, work on the more machine learning, AI approaches. But in order to do that exciting stuff, you need that foundation. We only started or figured out doing like risk order fraud after years of sort of building that base and working our way up. A startup could maybe circumvent some of those because they're a bit more nimble. But in order to do things right and do things at scale and are building for the long term, you kind of need these foundational layers first.
And it's interesting, we have two real good industry guys, and not that you're not industry, but you're really plowing into the deep data on this stuff, but there's ethical issues here. We had a conversation prior to the panel discussion, Gustavo. We talked about that whole part of it. In your mind, what does that mean? Where is it going? What's going on? What are we watching for here?
Well, I think the question is, the question I think implicit, it opens up to society. That's what I'll try to talk a bit in my presentation. I think we don't exist in silos. I think these silos are somewhat artificial. I think we are outside our day jobs or outside of computers. We're interacting with all kinds of friends, family, different people. I think the questions are the societal questions. How can we protect our privacy? How can we avoid human rights abuses? So we need to wear those hats daily, even if our day jobs may seem far from that. But in fact, they're not far from these questions. We're embedded in these questions in our contexts.
I just think it's important for us as citizens to realize everything we do is captured. So you're talking about mobile phones. I've noticed that there's a lot more geographic inputs into a statistical model now. Now that I know where I can track you, where you are when you're doing certain things, I can incorporate that to my model. And one thing that always surprises me is that criminals leave their cell phones on when they commit criminal acts. I mean, that's, if you ever think of doing something nefarious, turn off your cell phone, leave it somewhere and go, because it's very easy to start tracking that. But it's so easy for the law enforcement, that's kind of funny, but organizations can now start picking up on that as well. So there's an ethical issue there, because if you're modeling and you start getting geographic information into your model, you may be modeling on social demographic or race if you have a preponderance of people living in a certain area. Mm-hmm. So your fraud models may pop very much if you live in a certain area, or you may pay more for house insurance or car insurance, or to get a bank loan may cost you more just because of where you live. So that's kind of...
Sort of like insurance works right now, but it's true.
Just another example within e-commerce itself is that of price discrimination. For example, we could, in e-commerce solutions, we could offer different prices for different people. but it's an ethical dilemma. Some of the academics write that that's unethical to do so. Let's say if we're going to, the machine learning algorithms cannot even be explained easily. So I'm going to say, well, if you clicked here, if you went there, and that's your profile, is going to be embedded within the model. But it's, for example, I've heard of certain systems of buying air tickets. That if you buy air tickets with a Mac, I mean, the model is going to say, well, if you have a Mac, you're more likely to actually spend more than if you use a PC. So they're going to increase the price of the air tickets. Mm-hmm. But at the same time, if I talk to my neighbor, say, oh, I got a deal, then my neighbor is going to say, oh, I didn't get that deal. What's the difference? It's really hard to explain these things. We have to think through. And again, I think we need to involve more people in these kind of discussions.
So it's estimated that the image and voice search will make up 50% of all searches in 2020. That's pretty interesting. This goes back to some of the stuff that we were talking about before. So back to Cameron and Ed. Predict 10, 15 years out. What's that going to look like? I mean, we know what we're doing right now with our devices, with the data. We know how to mine. We know all that stuff. Just take a look into the future for us a little bit.
I'd love to see Shopify one day or any e-commerce platform one day where I can sign up and I can just start speaking. Like, I'd like to build a sandal store. I want to market this, these demographics. I'm located in this area, and I want this kind of lifestyle brand. And you can think of that as like a search, and the background algorithm is mining this massive search space, looking for like, okay, the user wants so-and-so print or so-and-so constraints, and it returns to you a pretty good e-commerce store. It's well designed. It looks good. It might even recommend where to find sandals from like a inventory supplier for the best deal. That would be like pretty amazing. But that's a Shopify specific example. But you could extend that kind of idea to trip planning as well. Like, I want to do this destination wedding. I like these hotels. I didn't like this on my last trip, and so on and so on. These are all search questions, and the algorithm's mining some massive search space.
So I think we've hinted at it a little bit. The most recent Google Maps features announcement is kind of where I see a lot of search interaction going, where you're able to interact with the things right next to you. You're able to see, the Timmy's downstairs, how many stars it has just by waving your phone around. You're able to see multiple floors of the building, and you're able to see the ways you're supposed to walk to get there. Not necessarily in here, because I don't think the streetcar came through this room, but I got one. But that kind of thing, what we're saying about contact lenses and virtual reality, that level of filtering just by walking, once we introduce it to children, is going to grow very, very rapidly, I would predict. And I think it will be, I would be curious to see what the inputs are in order to interact with that kind of space. But I anticipate that kind of interaction will be the future of search. But I mean, not exclusively. I'm sure those of us who still have desktop computers can still type things in if we want to do that.
So do you think, and this is, I'll get to this research in a minute, but do you think retail stores are obsolete? Do you think in the future they're going to go away? I have a 15, 13-year-old, and they still love going to Bayshore. But 50% of the time, they're at home saying, I want to buy something online. Look at this nice shirt. And it's cheaper, and I don't have to take a bus anywhere. They do it for the adventure, to be honest with you, not necessarily for this shopping experience anymore.
Stores aren't going to be obsolete until pressure selling stops working.
Until which, sorry?
Pressure selling. Yeah. As long as salespeople are able to push companies further into the black, then a sales space will have a reason to justify its expense.
I think also we're seeing a convergence of the channels, meaning the in-store experience feeds into the online experience and vice versa. For example, we can think of the shopper being identified when she or he walks into the physical retail store, and then having all the history from the online purchases there to help with recommendations, with loyalty points and all of that. So we're seeing that already today.
Yeah. Let's talk about the science again, because you guys love that stuff and you do it ad nauseum. So what's your prediction 10, 15, 20 years out? What's that going to look like? You know where you are today, but what's the trend looking like? Where's it going? Actually, it's kind of funny asking that because that's what we're doing, right? We should be able to predict this out and just push a button and say, here's where we're going to be down the road. Anyway.
I think that, my whole history is that of someone who spent time in the academia, and then after finishing masters at ORU, I went to the industry, I guess. I would like to turn the question to the audience and kind of encourage especially young researchers to think and dream of what can we do, not only in the e-commerce space, but in all different spaces. I think we have creative people too. And the university is a very good place for you to try out new ideas.
Yeah.
Well, I think the possibilities for data scientists and the ability to profit and receive value from your data is going to increase going forward just because of the volume and the technology. So once we start getting in voice and face recognition, and we start pulling off, different pieces of information from a picture, I believe that our models are going to be very, very good, and we're going to be very, very good at micro-segmentation. So I'll know just because you wore a pink shirt on a Thursday, you have a higher propensity to buy Chiclets gum, and that will be real time at the vendor. That is fraught with some very scary ethical things because, if someone has that much information about you, the whole reason for data science is to discriminate. That's what we do. I take data, I discriminate people and say, these are the people that get this offer. As we get more information, the ability to discriminate is going to be that much more powerful. So as data scientists, we have to kind of be leery about that, and also data citizens. So you should really know, like I teach my children how much data is out there. I have young kids, you say one thing online right now, it's never going away. And it could impact your ability to get a job 20 years from now.
Yeah.
So the possibilities are great, but so are the kind of the dangers, I feel.
And I would add one more thing, it's the influence. It's the marketer guys like me that go out, use that data to go and push it, which goes back into the whole ethics thing and also goes back into safeguarding your information because, you could be the next Shopify could get hacked. You don't know, and that information can be out there. And I know you're safeguarding
Unlikely.
that right now, highly unlikely. but Amazon, anybody could take the data and go do stuff. And I say to my kids all the time too, be careful of that. We've got T-minus 10 minutes, and I want to go to the audience because I think it's a lot more fun going out to the audience and asking questions. So, sure, just line up at the mics here, and then we'll just tag team back and forth.
Yeah, my question is, we've been talking entirely about big data in the hands of corporations, government organizations, but as technology progresses, are we going to have to start worrying about the big data that I personally own and what I can do with it? As in my phone, say, can overhear probably hundreds of different conversations every day. I interact with tons of people online. Eventually, it's going to reach a point where I personally can probably exploit that information somehow to my own advantage. So we're going to need sort of a private or personal GDPR for that sort of information that just the individual person can collect.
Would you want to not restrict yourself from seeing your own data?
Well, it's what I can do with the data that I collect about, say, everybody in this room for my own personal advantage, potentially. I'm not saying I can do that today, but with the increase of technology, we're saying that, Moore's Law and everything that's overpowering what we can do with information, pretty soon I will be able to exploit just the data that I own personally, not as a corporation, not as a government, not as an organization, just me.
Yeah, one extreme case of that is if you walked around every day with a video camera and just recorded everything you saw and whatnot. And I think that's where the law comes in and says, you have to like not do that. Or there's restrictions to that. You can't film some things. Yeah, I actually don't know. That's a really good question.
It doesn't immediately strike me as something you shouldn't be allowed to leverage. I mean, like, if you give witness testimony in court, you're essentially relying on the same thing. What you're suggesting sounds to me like a more objective and reliable way to do that. So I'd say no. I think people should be allowed to collect their own data based on their experience with respect to current laws. So you can't go around recording people's voices in the current society with video. But with respect to those laws, I think you should be able to collect whatever you want, as long as you're not stealing it or going into private property that you don't have the permission to access, anything like that.
Okay, thank you.
So I can see a release coming soon that says it's okay for you to record me in this room.
You're being recorded right now.
Yeah, I knew that. Yeah, I got that.
They're putting glass doors on.
Yeah,
we're just
okay.
it's being
So
tweeted out.
there'll be glass posts too. So the question is, if you have to think about the data structure in the future, because we're going to have not just data, we're going to have the voice and the video on top of that. So what's that data structure look like that you can collect things in? And we know that there'll be processing for it, but how are you actually going to organize it so that you can actually take advantage of it, because it is about statistically discriminating?
I suspect the big data guys might have a better answer.
Well, we already do that with unstructured text right now, so we can count up frequencies of terms and store it like that. But I think what you're alluding to is there are other technologies from a big data perspective, rather than the traditional relational database management system, that would be very hard to do in an efficient way. So things like graph databases and elastic searches are already being employed, where they can search out and query data at a much more effective way. So they're already starting down that road right now.
Just the other comment is that I think NLP is becoming a commodity, meaning we already have Google doing NLP, doing sentiment analysis, doing entity extraction. So I think the next interesting question is what do we do with that data? So since we have that, we passed the hurdle of analyzing the actual sound, analog sound. Now we can actually handle the data.
Okay, next.
So the algorithms are built to converge towards the behavior and predict the behavior. My question is, how does the behavior converge towards the algorithms? I'm noticing things like YouTube or Google, where it's less towards, they're catering to you, so you're converging to the algorithm and what you see, as opposed to the algorithm converging to what you want to see. And what are your points on that?
Yeah, there's, I mean, Facebook could be malicious and start removing food posts that have meat in it if they want to produce like more vegetarians in the future or something. Like there's no really oversight to control that, and that food example might be silly, but maybe there's a bug in the code and the image reco says like, oh, this meat looks like something inappropriate, and I shouldn't flag it, therefore I'll promote this like vegetarian post over the food one or the meat one. Silly, but like potential, and that's like an example of us converging towards what the algorithm is already displaying, rather than the opposite. So I think it could be happening right now. Other examples?
Your model's going to be better, because it's a self-fulfilling prophecy, right? So if I predict certain things happening and you start behaving like that, there's going to be a data scientist that's getting a little star on his report. So
I find a lot of UX people I'm dealing with, or site content people, are very focused on getting the user to do what I want now. So like the most common metric in our industry that I tell people not to use, that constantly gets used, is conversion rate. Just because, and that's just for, if not everybody's aware, it's just transactions over sessions. But you're not selling things to sessions. You're selling them to users. Like I've never understood the insistence that I want to see success and I want to see it now. In general, I've seen people getting smarter with adding a wider tail to people's behavior and stopping this like, this is the page and I want them to click that attitude. But it's been slow going. And if they can tie, minuscule hit-to-hit interactions that they want to their company's goals, they're going to prioritize that above making you happy for now, until it costs them something.
Next question.
That's a very, very interesting discussion because obviously because of all the infrastructure required to make that happen, you need to make money at one point. Otherwise, you cannot run all those computers to make that happen. Google or whatever, it could be one of those larger, or let's say, organizations to sell and they have those warehouse to make that happen. But things were like that were predicted about 20 years, 15 years ago. I know when my colleague now in Dubai, we wrote about that. We knew when I was going to move to a restaurant or a place, things would be known. I would be tracked and become a victim, not really. Or I consider I'm better served. So I accept the fact that I trade a bit of my privacy to get better service. But like our guy from Spotify, I think we will have more connection than ever with the reality around us because of the connectivity we will have. Will this increase the capability of the young generation to be smarter? I don't know. That's my main question here. If we do something on purpose, can we increase the quality of life of the future generations?
Anybody?
That's a good question. The short version is that thank goodness they're putting courses in schools that teach kids how to identify fake stuff online. If we do that, then yes. If we don't, no. It's way easier to spit out garbage that's not true, and we see a lot of it these days. If we can educate people to be critical thinkers, that'll work. If not, it'll be more noise than signal, and people will get stupider.
You know, I have something. I like to think that people are going to get smarter, but a lot of this is done in the back before anybody can ever see it. I'm going to give you a quick example. I do a lot of unstructured data mining, and one of the things I wanted to come to my managers was a subscription where I could go to an organization and you upload what you consider 100 good CVs of people that you want to have and 100 bad. And then when you hire someone, I'm going to build a statistical model to predict whether it's actually a good hire or a bad hire by their social media or internet profile. And I thought it was a great idea. It's like $2,000. I can get this cranked out in 4 weeks. And then I started thinking about it. People would never get a job if everybody bought this, and they would never know why. So I agree it's important to, be educated. But you would literally be one of those people that went and just dropped CVs, and if everybody was using this type of software, you'd never know why you didn't get hired. And then I said, you know what, I could drop it at $250 on a dating website and have a creep meter. And I got to go do a search, and I got to come back with a high score of a creep meter. And that person would never get a date and never know why. So it's important to be...
man, we got to talk later. There's people that don't know. Hold on a second. I got we're done, but we'll do too quick. Okay. Too quick, yeah. Sorry.
How do you deal with malicious people polluting data on purpose to change the models that you have?
It's a big problem. Well, ideally would actually try to filter out statistically. But if it is a good malicious person, the person will also create a statistical model to bypass the filter. So it's a big problem.
Thank you.
Hi. So I'm going to preface this with all of the hoopla around Facebook and Google and their involvement recently in testimony and people's privacy and selling ads. I think we all know that it's obvious that it's an ad model, right? Like you're sacrificing your data to get an experience. We all get that, but not everybody does. And you said something really key. If people are educated, I think all of us can agree that I'm from the States, so especially there, and it might be better here, but education needs reform. We need to teach people how to think, not just fill them with knowledge, right? So all of these technologies are developing so fast, and as data scientists, you understand them explicitly, but the general public does not, and does not understand necessarily how that interacts with them. So now I have a hard time believing that companies are self-regulating, but what are you guys doing within your respective companies to collaborate with social scientists so that you steer clear of those ethical issues like higher pricing for airline tickets or products based on what your algorithms think a person is or who they are? Because it's moving so fast, like we need to have insight. And what are you guys doing within your respective industries to address that?
If we can start. GDPR has what could be interpreted as the rights to explainability. There is, if your data is being used by some, especially autonomous algorithm, it has to actually explain what it's doing with your data. The other part, I think, about the social sciences, yes, we have to explore what these things entail. And there are forums, like I spoke about the rights conference that happened in Toronto, that happens annually. There's a book called Programming Models Ethics or Programming Ethics. I think it's a bit naive for computer science itself to say, and what this field of work tries to do is to say, we're going to actually encode ethics and actually solve the ethical problems with computer science. I think it's naive. Again, it's saying, okay, we know everything within our field. We can actually encode this problem with ethics. I think we have to really engage with other fields and with society at large with these problems.
I think we're going to have to cut it off, unfortunately, right there. But thank you so much. There's a great quote by a vice president at Gardner that said, information is the oil of the 21st century and analytics is a combustible engine. I know we're moving into electric cars, but we're still in our infancy of what would be a combustible engine as it relates to big data. So I'm looking forward personally to the future and see what it has to hold. It's scary and exciting at the same time, and the people that are sitting up here are charting the course for us. And we're in their good hands, so thank you very much for leading the way. Give them an applause, yeah. That concludes our session, and we're on to the next one. Thank you, John.